press the bell icon on the YouTube app and never miss another update.
Namaste children. Let us continue with the topic organisms and populations. Today we will discuss growth models based on availability of food and space. So in the last class we discussed about the population density. So in that population density, so under population density we have four factors: natality, mortality, immigration and emigration. So in these two, natality and immigration increases population density. It increases population density, whereas these two, mortality and emigration, decreases population density. It decreases population density. So under normal conditions, these two, natality and mortality, are very important factors. So under normal conditions, natality and mortality, that means birth rate and death rate, are very important factors which determines the population density, and these two are considered under special conditions. These two are considered under special conditions. Understood? This is about population density. 2 marks keltare. Name the factors which influences population density. Avaga natality, mortality, immigration and emigration you have to write. For 1 mark they may ask, name the factors which is responsible for increase in population density. That time you have to write natality and immigration. The factors decreases population size is mortality and emigration. And they may ask like this also, under normal conditions, which two factors are going to influence population density? See, under normal conditions andaga we have to go with natality and mortality. Which two factors are considered only under special conditions andaga we have to go with immigration and emigration. Understood? That is about population density. Then we will move with the growth models. So we have two types of growth models based on availability of food and space. So based on availability of food and space, we have two types of growth models. One is exponential growth model, another one is logistic growth model. So this exponential growth is seen when resources are unlimited. When resources are unlimited. Logistic is seen when resources are limited. When resources are limited. Understood? So there are two types of growth models based on availability of food and space. Understood? Exponential yavag noಡ್ತೀವಿ when resources are unlimited. Logistic growth model we see when resources are limited. So we will go in detail about these growth models. exponential growth, or it is also called geometric growth model or J-shaped growth curve. So this type of growth model we see when resources are unlimited. When resources are unlimited, that is food and space. When resources, that is availability of food and space, is more, then we see increase in the size of population. That gives us exponential growth. So Darwin told that even large size animals like elephants will increase in their number when there is availability of food is more, space is more, and if there is no predators. Understood? Like this, when we plot the growth against this time t, this is population density, which is denoted by N. We see initially lag phase, then we see increase in the population. Why initially we see lag phase antandre, here the organisms will take time to adapt to their external environmental conditions. That means, so in the last class we discussed that natural selection is going to be worked at population level only. That means group of individuals will decide which habitat is favorable for them, for their survival and also for the reproductive purpose. So that for that reason, initially we see lag phase, then once they adapt themselves to that environment, they start increasing in their population size. That's why we see acceleration or increase in the growth of the population. So in this exponential growth is denoted by if population density is denoted by N, then the population size at unit time T is then N at unit time T is, or unit period T is denoted by, how we are going to calculate, that is by dN by dt equals d minus d into R. Then what is B? B is per capita birth. D is per capita death, per capita birth rate and per capita death rate. B denotes per capita birth rate, D denotes per capita death rate. Understood? Then population size at unit time T or unit time period T is given by N is initial population size. So this B minus C is R. R is rate of intrinsic rate of natural increase. Intrinsic rate of natural increase. So this R is nothing but reproductive fitness, which decides the influence of both biotic and abiotic factors on the population size. So this R is nothing but reproductive fitness that also influences, it decides the influence of both abiotic and biotic factors on the growth of population size. When coming to the R value, this is unit time is T. The R value, it is very important factor which decides the population size. R value for Norway rats is 0.015 and for floor beetle it is 0.12. R value. And according to 1981 census, R value for human population is in India. Human population is 0.0205. This all you have to remember for your competitive exams. Norway rat R value is 0.015. Floor beetle it is 0.12. And in 1981 in India, the R value for human population is 0.0205. So this is about the exponential growth. And in this, if the R value increases, that denotes increased population size. Higher R value denotes increased population size or density, and lower R value denotes decreased population size. Understood? If R value is same, that denotes stable population. This is about the exponential or geometric growth or J-shaped growth curve. This we get when resources are unlimited. The equation of this dN by dt equals Rn is also written in the form of integral form of equation. If you know with basic calculus, we can write this equation in the integral form also, that is nt equals, here nt is population density after time t. This is population density at time 0, where R represents intrinsic rate of natural increase, then E represents base of natural logarithm, that is value is 2.71828. This is the value of E. So if you know with the basic calculus, we can derive this equation in integral form, that is Nt equals N naught ERT. So here Nt represents population density after time t. This is initial population, it is final population. So Nt is population density after time t. N naught is population density at time 0. R represents intrinsic rate of natural increase. E is the base of natural logarithm. Its value is 2.71828. Understood? Then we will move with another growth model, that is logistic growth. So the logistic growth curve is also known as sigmoid growth or S-shaped growth or Wurst curve growth model. So this we see when resources are limited. See, what we discussed, exponential is not realistic one, because in nature one or other day the resources are going to be limited. One or other day resources are going to be limited. Hagagi logistic is very realistic one, because this curve or this growth we see when resources are limited. So this growth curve we get, this is time t. So initially we see lag phase, then increase in the population, that is acceleration, then decrease in the population, that is deceleration. Understood? So this is lag phase. And this one is acceleration. And this part is deceleration. And after that they have mentioned asymptote. Asymptote andre it never reached a straight line, but this little bit increase or decrease we see like this. So this is called asymptote, but it will be near to straight line. It will be near to straight line. So that is called asymptote. But in your book they have given straight line like this. So this growth curve initially again lag phase. Why it is lag? Because initially it will take time. Organisms will take time to adopt themselves to a habitat. They take time to adjust themselves to habitat. Once they adopt themselves, they increase in their size. Then once it increases in its size, it decreases. So I think I'll write this here. This is carrying capacity. See here, initially they take time, then they increase their number, then they decrease their number. So why initially they take time? Because they need, that is lag phase. Here the organisms will adjust themselves to the external environment. That's why they need time to adjust themselves. Once they adopt to their external environment, they start increasing in their population size. That phase is called acceleration phase. After that, they decrease in its size, deceleration. Why we see decrease in the population? Because here resources are limited. Because of the resources which are limited, resources are there, they start decreasing in their size. Because once the population increases, we see competition among them. Either we see intraspecific competition, also interspecific competition. So in this competition, if the competition occurs for the same resources between the similar species, the fittest, the superior one is going to survive and inferior one is going to be eliminated. The fittest one is going to survive and reproduce. Understood? So once the resources are limited, we see the decrease in the population size, that is called deceleration. Then asymptote. Asymptote means, as I told, little bit increase or decrease in that area, but it will never reach the straight line. In the logistic growth, we see carrying capacity. Nature's carrying capacity means in nature some resources will be there that helps in the survival of species, that helps in the survival of certain number of species. That is about carrying capacity. Nature's carrying capacity means under resource, when resources are limited also, in nature some resources will be there that supports, that helps in the survival of species. That is nothing but carrying capacity. So this growth model equation is denoted by dN by dt equals Rn . So here N denotes population density at the time t. Then R is intrinsic rate of natural increase. K is the carrying capacity. K is the carrying capacity. This is the equation. So in your exam, they may ask individual, explain the growth model when resources are limited ಅಂತ ಕೇಳಿದ್ರೆ you have to go with logistic growth model. If they ask explain growth model when resources are unlimited, then you have to move with exponential. For 5 marks, they may ask explain growth models of population, then you have to describe both exponential and logistic. Understood? Next, we'll write the difference between logistic growth model and exponential growth model. In the exponential growth, we'll draw this. This is time and this is population density. Okay. We see growth, J-shaped growth. So this type of growth we see when resources are unlimited. Understood? Then it is denoted by equation dn by dt equals Rn, or in integral form it is nt equals ERT. And in this, carrying capacity is absent. Carrying capacity is absent. And it is not realistic one. Why it is not realistic? Because in nature, one other day, resources are going to be limited. So next, this is population density and this is time. So this type growth model we see in logistic growth. So when we see this, when resources are limited, when resources are limited, it is denoted by so carrying capacity is present and this is more realistic one. So that is the difference between exponential growth and logistic growth. Understood? So this we see when resources are unlimited and carrying capacity is absent, and it is not realistic one. Why it is not realistic one? Because one other day in nature resources are going to be limited. Whereas in logistic growth we see this type of growth model when resources are limited, and carrying capacity is very important when resources are limited, because nature's carrying capacity supports, it is having some resources that supports the survival of species, and it is more realistic one because this type of growth we see when resources are limited. Understood? This is about the difference between logistic growth and exponential. Exponential is also called geometric or J-shaped. Geometric or J-shaped. Logistic is also called sigmoid or S-shaped or waltzed or logistic growth curve. This is the difference between these two. So in the next class, we will discuss about the population interactions. So in the interactions, we have two types of interactions. Intraspecific interactions and interspecific interactions. Under population interactions, the population interactions, we have two types. Intraspecific interactions ಅಂತಂದ್ರೆ interaction occurs between the same species. Interaction occurs between the same species. Interspecific means interactions occurs between the different species, different group of species, between the different group of species. So, intra means interaction among the individuals belonging to same species is called intraspecific interaction. Interspecific andre interaction occurs between the species which are belonging to different groups. So, in this we are going to discuss predation, parasitism, competition, commensalism, amensalism, and mutualism. So, these 6 types of population interactions we'll discuss in the coming class. So, in the predation and parasitism, one species is going to be benefited, other is going to be harmed or killed. In the competition may seen between the same species or between the competition may occur between the different species for the same resources also. So, in this we see both sides harmed, both species are going to be harmed during competition. In this, the superior one may survive and inferior one may eliminate it or it may become extinct. Commensalism alli one species is benefited, other species is neither harmed nor benefited. Amensalism alli one species is harmed, other species is neither harmed nor benefited. Whereas in the mutualism, both species are benefited. Understood? So, this is we are going to discuss in our coming classes. So, in the population interactions, we have 6 types of population interactions. So, in these interactions, these population interactions include both type intraspecific interaction and interspecific interactions. Intra means interaction occurs between the same species. Inter means interaction occurs between the different species. In that we have 6 types: predation, parasitism, competition, commensalism, amensalism, and mutualism. Understood? In this predation and parasitism, one species is going to be benefited, other species is either harmed or killed. Competition, both species are harmed. In commensalism, one species is going to be benefited, other is neither harmed nor benefited. In amensalism, one species is harmed, other species is neither harmed nor benefited. And mutualism, both species are benefited. So, that we will discuss in our next classes. Understood? So, in the today's class, we have to remember about the growth models. So, based on resources availability, there are 2 types of growth models, have the exponential and logistic. So, exponential is seen when resources are unlimited and logistic is seen when resources are limited. Understood? So, this is about growth models. In the coming class, we will discuss about the interactions among the populations. Understood? Thank you.